For generations, Mars has captured our imagination, a rusty beacon in the night sky, raising the question, could life exist beyond Earth? NASA's relentless quest has sent orbiters, landers, and rovers to peel back the Martian mystery, revealing a world once warmer, wetter, and perhaps more Earth-like. Ancient riverbeds, polar ice caps, and evidence of vanished oceans hint at a dynamic past. The search for life on Mars is a search for a second Genesis, a separate origin of biology in our solar system. Even the faintest sign of life would change our understanding of the cosmos. Our robotic explorers are our eyes and hands, sifting through Martian dust for clues, but Mars guards its secrets well, offering only hints and tantalizing clues. The Perseverance rover's latest discoveries aren't fossils or alien ruins but something subtler, and perhaps more profound. We've found not life itself, but the preserved ingredients for life in an ancient Martian lakebed. This shifts our focus, not just searching for life, but for the chemistry that could make life possible. The story unfolding in Jezero Crater may be the prequel to the story of life beyond Earth. Here the real adventure begins. Picture Jezero Crater, once a vast lake fed by a mighty river, chosen as the landing site for NASA's Perseverance rover. Its mission: explore this ancient river-lake system for signs of past microbial life. Perseverance found not just rocks but a layered geological record of water's presence and activity. The most exciting finds came from fine-grained sedimentary rocks, prime candidates for preserving organic traces. In these mudstones, Perseverance detected the highest concentration of organic molecules ever found on Mars. Using its Sherlock instrument, the rover mapped a diverse array of organics embedded deep within the rocks. These molecules weren't scattered randomly, they were concentrated in specific layers, corresponding to different eras in the lake's history. Each drilled core sample is a time capsule, preserving secrets from billions of years ago. This is the closest we've come to finding potential biosignatures on Mars. What are these organic molecules? On Earth, they're the building blocks of life, carbon-based compounds like DNA, proteins, and sugars. But life isn't the only way to make them. Volcanic activity, chemical reactions, and meteorites can also create organics. The discovery in Jezero Crater presents two possibilities. These molecules could be the result of non-biological processes, or they could be remnants of ancient Martian life. Abiotic processes like water-rock interactions or meteorite delivery are known to happen and would still be a major discovery. But if these are biosignatures, they could be the chemical fingerprints of long-lost Martian microbes. Right now, Perseverance can't tell the difference. Its instruments are powerful, but to know for sure, we need to study these samples back on Earth. The next step is bringing Mars home. When searching for life's ingredients on Mars, we must be certain we didn't bring them from Earth. NASA built Perseverance under the strictest cleanliness protocols. Assembled in sterile clean rooms, components baked and scrubbed to remove contaminants. The rover carries witness tubes to detect any earthly contamination that might sneak into the sampling system. If a molecule appears in both a Martian sample and a witness tube, it's likely from Earth. Sherlock helps distinguish between surface contamination and molecules embedded deep within Martian rocks. The organics Perseverance found are concentrated in ancient geological layers, not on the surface. This careful approach gives scientists high confidence. These molecules are genuinely Martian. The evidence is compelling and native to Mars. Let's be clear. Finding organic molecules in Jezero Crater isn't proof of life. We haven't found fossils or living microbes, just the building blocks. It's like finding a stocked kitchen, not a baked cake. This discovery confirms that Mars could naturally create and preserve the chemistry needed for life. For years, we wondered if these conditions were unique to Earth. Now we know they're not. Mars had the right ingredients, in the right place, at the right time. The presence of organics in an ancient lakebed is exactly what we'd expect if life ever existed there. These molecules survived for billions of years, preserved in rock. Mars has passed a key test. The processes that may have led to life on Earth could have happened there too. The question now isn't if the ingredients were present, but whether life ever took hold. The implications of this discovery stretch far beyond Mars. If life's building blocks can form and persist on Mars, what about other worlds, like Europa or Enceladus, with their hidden oceans? These icy moons may have all the same ingredients, plus liquid water today. Mars gives us a reference point for searching for life's chemistry elsewhere, even on exoplanets orbiting distant stars. The universe is a chemically creative place. The laws that shaped life here operate everywhere. Water, carbon, and rocky planets are common. The stage for biology is set on countless worlds. The question is no longer, are the ingredients out there, but how often does the recipe lead to life? Perseverance's instruments are powerful, but to truly understand these Martian organics, we need to bring the samples to Earth. The Mars Sample Return mission aims to do just that, a complex, multi-stage relay to collect, launch, and return Martian rocks. Perseverance caches samples. A future lander and fetch rover will collect them and launch them into Mars orbit. An orbiter will capture the sample container and return it to Earth, where it will land in a secure facility. Only then can scientists analyze the samples atom by atom, searching for definitive signs of biology or geology. This is our best chance to answer the age-old question, are we alone? The journey is long, but the reward, a handful of Martian dust, could change everything. The answer may be waiting, sealed inside a tiny tube from another world.